So this is section, once again, 2.9, part 3, proving lines parallel geometry. So I want to make it clear that the other day I had you write all those converse, okay? Can you go back in your notes because I made a mistake. First of all, the corresponding ones is a postulate, okay? So it'd be converse of corresponding angles postulate, right? Okay, the next 4 are theorems. And this book does classify them as theorems. I didn't read far enough. They are theorems, but I didn't know. So I wanted to go back and look. Yes, they are theorems. They were right there in front of my face. So those are alternate interior, converse of alternate interior angles theorem, converse of alternate exterior angles theorem, converse of same side interior angles theorem, and converse of same side exterior angles theorem. So those are all theorems. So please put THM on the back of them. Okay, that's my bet. So you will identify them as those. So in the assignment, go back and put theorems and postulates on there because it's kind of a big deal. Okay? So here's a problem that you're going to be working on that is similar to what you're going to be working on in the assignment. And this is, what it says is that you have this picture and you have these two angles given, this angle here and this angle given. It says find angle MRQ, which is this angle right here, so that A is parallel to B. So this is A and this is B. Forgot to put those on there. Identify the postulator theorem that tells you that. Well, what kind, if these two lines are parallel, what can we say about these angles? They're congruent because they're what kind of angles?
Alternate interior.
All right, they're alternate interior angles. So we would say that 5x plus 7 would have to equal 7x plus a negative 21. Is that correct?
Yeah.
Yes. And
Wait, how do we know if they are?
we don't. It says find it so that these would be parallel.
Okay.
So in order for that to happen, you're right. We don't know, but it's saying, hey, what would the values have to be in order for this to be true? Okay. So now we're going to subtract 5x from both sides. And we get 7 equals 2x plus a negative 21. And I'm going to subtract a negative 21 from both sides. And that means we're going to add it, right?
Mm-hmm.
And so I would get 2x equals 28.
X equals 14.
So x divided by 2 equals 14. So now I have to put 14 back in this, because this is the angle I'm looking for.
77.
So I would take 14 times 5
7.
plus 7. So 14 times 5 is 70 plus 7. This is 77 degrees right here. Okay, does that make sense to you?
Yeah.
MRQ would have to be 77 degrees. Make sense? Okay, so I want to show you something, and I hope they watch it. So you're going to do 8 through 22. So 16 through 21 are like that. 22 is kind of a story. You know what? Let's look at 25 together. Okay, so 25, I want you to do it with me. All right?
Do we do it on our assignment?
Yes, do it on your assignment.
It's not on the assignment.
Yeah, but I'm going to do it with you. That's why it's not in there. Okay. All right. I want to show you a proof for the first time. It's called a two-column proof. Okay. Now it's called a two-column proof because it has two columns. All right. In a two-column proof, this is the way it looks. We start with a given, which in this case is angle 1 is congruent to angle 3. And line segment AC is parallel to line segment BD. And we want to prove that line AB is parallel, line segment AB is parallel to line segment CD. Okay? So in a two-column proof, there's always a given and there's always a proof. And then there's a picture. Now if you do not put the picture, you're going to be in trouble because it gets points also. This is A, this is B, this is C, and this is D. This is 1, 2, and 3. So I will let you write that out. Okay. All right. Every proof has to have given and approved and a picture. And then here's the two column. Here's the two column. It looks like a T table, a huge T table. And we call this the statements, and this the reasons. Okay? So if I make a statement, I got to give a reason. Let me tell you, there are 4 reasons. Okay? There are 4 different kinds of reasons. Now this is off to the side. Okay? This is off to the side. There are 4 reasons. The first one is given. The second one is a definition. The third one is a postulate. And the fourth one is a theorem. Those are the 4 reasons that you can give. Okay? Anything else you cannot give. All right. So let's begin. When you're given a given, you mark what you know is true. The author says this is true and this is true. So we know that 1 is congruent to 3. So your first step is to mark that those 2 angles are congruent. And then we know that AC is parallel to BD, so I marked those. We're trying to prove that this guy is parallel to this guy. Now, there are 5 reasons to prove that 2 lines are parallel. We learned them yesterday. If corresponding angles are congruent, if alternate interior angles are congruent, if alternate exterior are congruent, if same side interior are supplementary, if same side exterior are supplementary, right? Those are the 5. Okay, so we have to pick one of those 5 to prove this is true. So our last statement is going to be AB is congruent to CD. Always. This is going to be our last statement. If this is not your last statement, then you have your proof wrong because this is what you're trying to prove. Yes?
It's parallel, not congruent.
What's wrong?
You said congruent.
Oh, did I say congruent?
Yeah.
It's parallel. I'm sorry. Yes?
So if we say alternate exterior angles?
I don't know yet. I haven't looked at it. Okay. Alternate exterior. I don't believe those are alternate exterior.
Oh, no, those are
All right? It would be over here.
the alternate
Yeah.
interior.
Let's take a look though, before we get too excited. The first statement is always your given. Angle 1 is congruent to angle 3, and line segment AC is parallel to line segment AC is parallel to line segment BD, and this is given. How do I know it's given? The author told me. You got it. Josh, we good?
Yep.
Okay, so this is congruent to this, all right? Now, they also told me that these 2 were parallel, right? So if these 2 are parallel, what's the relationship between 1 and 2? Yes, sir.
Alternate interior.
Okay, are they congruent then?
Yes.
Okay, so 1, we write that. Angle 1 is congruent to angle 2 by the alternate interior angles theorem. Now, it's not the converse. Do you understand that? We're saying the lines are parallel, these 2 are equal, right? So now we can mark that 1 is congruent to 2. Now, if 1 is congruent to 2, what can we say about 2 and 3?
They're congruent.
They are congruent. All right? They are congruent. So angle 2 is congruent to angle 3. But do you know why? I said it yesterday. If 1 is congruent...
The money.
Yeah, the money thing, which we call the transitive property. Now, I'm going to show you something. Do you see property as one of the reasons?
No.
All right, the transitive property is a postulate. These are the same. Okay? Some people call it the transitive postulate, but it is really called the transitive property. All right, so 2 and 3 are congruent. Now listen, if 2 and 3 are congruent, what kind of angles are they?
Supplementary.
No.
Oh, they're,
The weird one.
Sorry.
The one that I always say everybody forgets. The corresponding one.
and yeah.
And that's the first one we learned. So if corresponding angles are congruent, what can we say about the lines?
They're congruent.
No,
They're parallel.
they're parallel. Remember yesterday, the converse of the corresponding angles postulate says, if lines are cut by transversal such that the corresponding angles are congruent, then the two lines are parallel. So therefore, this is number 4. Why? Because of the converse of the corresponding angles, and this is a postulate, isn't it? It's the only one that's a postulate. The rest of them are all theorems.
What's the difference between them again?
Okay, a postulate, Uton, is assumed to be true, but we don't have a proof for it. A theorem can be proven with a formal 2-column proof.
So if we were to swap out,
Theorem and postulate is wrong, because in this book, a postulate is not proven. Okay? All right? Yep. Okay, you see how this works? So the first statement in a proof, let me tell you something, in a proof, you should get these points. This is worth 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. This is worth 10 points. These are the points you should get right, and even if you don't know how to do a proof. You should get this, 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 and this. So out of every proof, you should get 50%. If it's 10 points, you should get 5 points out of it. Why? Because they give you this. Now on a test, this will all be given to you. So you'll only get to do this. But you should always get this, this, and this right. Right? Because this is our first statement, this is our given, and this is what you're trying to prove. You should always get those right. Questions? Okay. All right. Let's look at 22 together. Would you read it for us, Greeley? Page 190, number 22.
Wooden picture frames are often constructed using a milter box or milter saw. I said milter. Okay. These tools allow you to cut at an angle of a given size. If each of the 4 pieces of framing material is cut at a 45-degree angle, will the sides of the frame be parallel? Explain.
Okay. So, we have a picture frame, all right? We have a piece of wood, right? And what it's saying is it's cut like this and it's cut like this, right?
Yeah.
And then the next piece is cut like this, right?
Yeah.
And cut like this. That's how a picture frame fits together. But we can get a miter saw to do this, right? Why are this side here? Why is this side here parallel to that side here? Why is this side here parallel to that side? Why is that?
Because the transitive
Well, this is 45 degrees, correct?
Yeah.
Right? How big is this?
so it,
45.
so it's
Would it be
supplementary.
It's supplementary, isn't it?
So
This is
180.
135 degrees, right?
And so then you would use a transitive property, right?
What's that?
Because then you would use a transitive property like both said, and then
Okay. All right. Another way you could say it is, if this is 45 degrees and this is 45 degrees, what's this whole angle?
Right.
90. Is that what you were going to say?
Yeah.
Okay. All right. So this is 45 degrees and this is 45 degrees. They add 90, which means that it's perpendicular. And if it's perpendicular, they're perpendicular to the same line. All right.
So would it be the converse at corresponding angles?
No, it would actually be. I think it's in this section.
Same side exterior.
Maybe it's not. I thought it was.
It's not even in all, so we
Oh.
can't check.
Approved lines parallel. No, I thought it was. I thought if it said if two lines are perpendicular to the same line, then they are parallel. Yes. I'm sorry, page 187, 2.23. Perpendicular transversal converse. In a plane, if two lines are perpendicular to the same line, then they are parallel. Okay, so I'm going to put that down. The perpendicular transversal converse. The perpendicular transversal converse. Two lines. I got it. Two lines perpendicular to the same line are parallel.
Should we add it in a plane?
Yes, would you? So, both those angles are 90 degrees. They're both perpendicular to the same line. They are parallel. Okay? Any questions about that? All right. Would you shut me down, Joss?